let's see how far we can go. Okay, guys, now today we're going to talk about, I should say, the exponential functions. And for the exponential functions, we are going to do something very interesting. For the exponential function, guys, we are going to cover these concepts that before the period which we had before today, we talked about the logarithmic functions, correct? And now we just want to move on to the exponential function. But because it is of, I should say, critically important, I have to again write here for you on the top that we said that, guys, if you have a base which it goes to the power, let's say, x, if it becomes, let's say, f of x, you see that it becomes actually mutually represented by this notation that the log of f of x when the base is b equals to what? X. That was a logarithmic representation. That was, I should say, exponential representation. And what you saw that they are mutually the same, because you can move from the exponential representation to the logarithmic representation, or the reverse. You can move from logarithmic to the exponential representation, the thing which we talked about that extensively before. Okay, now we just want to now deal with exponential functions to see that how we can just solve them. I'm just going to solve one for you, then let's see what happens. Guys, the first scenario which happens, I'm just going to put that as a note here. Everyone can see this if I write it here? Yes?
Yes.
The thing which we have, guys, here is that when in these kind of cases, we say that, okay, if I have two bases, I have a base A, the exponent is by f of x. If this one equals to the same base, an expression to the right side to the same base, but the exponents of the other right side is g of x. Guys, you see that? Then I have two bases which they are equal, and I have two exponents which it seems that they are apparently different. I have f of x and g of x. If the bases are the same, then I come to the conclusion that if the bases are the same, then the exponents also should be equal. Huh? I'm going to give an example, and it should make sense, but at the same time, I hope that you have a good feeling that what does it mean? Okay, guys, are you okay? You understand this one?
Yes.
Yes.
How I can use that in order to solve a differential equation? Imagine, as an example, I put this like that. I have a function which its base is, let's say, 2. No, let's put the base as 3. And it comes to the exponent, which is, let's say, the exponent is, let's say, x plus 4. Then I have to the other side, I have the same, I should say, maybe 81, correct? Then I have this one here as a kind of a very basic example to tell you how this one may help us. And I ask you guys, please solve this equation. The first thing is that you first identify this equation as an exponential function, exponential equation, because the unknown, which is going to be the x, it's appearing as an exponent of the expression. It is not at the base that we say that, okay, it's a simple algebraic equation because our unknown, which is the x, is appearing as the exponent of the function. And then as a result, we say the first step, we identify this equation as an exponential equation. So far, so good, guys. Then if you are good, in order to solve this, I'm going to use the property which I introduced to you to say that, okay, if for two functions, the bases are the same, then I deduce that the exponents also should be the same. But the question is that now, can I work in a way to make the bases to become the same? Can I do that? Can you think of that, guys?
Yes.
Can I make, yes, Rose. Rose?
Yes.
You want to say something?
Make the base are both 3 and
That's so true.
80,
How can I do that?
81 equal to 3 power 2 4.
81 becomes what?
3 power 2 4.
3 to the power 4, you mean?
Yes.
That's so true. That's so true. Then as a result, I come here to write it 3 to the power x plus 4 equals to 3 to the power 4. Right? And now when at this stage, I look at this one, I look at the identity which I had before, guys. And when I look at this, I see that, okay, f of x and g of x should be the same, correct? Then I said that if the bases are the same, which 3 are the same, then I infer that x plus 4 should equal to 4. Then I can have a result that it says that x plus 4 should equal to 4. Then how much is x?
0.
0. Then x should be 0. It is one of the easiest way when you come to solve exponential functions. First of all, if you can say that, okay, the base can be equalized, I mean, you can find, you manipulate the base on one side, that you can write it in the same way, then you say, you can, okay, then I make the bases look exactly the same, then the exponents necessarily has to match, correct? Okay, in order to just, I give you one example. Let's do this example, guys. Imagine I have the equation like that. I say 4 to the power, let's say, x squared plus x should equal to 16, and the power is, I call that 3x here, 3x, and I say 16 to the power of square root of, no, it becomes, no, let me, not the square, sorry guys, write it 16 to the power of, let's say, x. Okay. Then 4 to the power x squared plus 3x equals to 16 to the power of the x. Can you please give it a try to see if you can solve this equation, please? Guys, are you done?
Yes.
You're done, girls, now?
Yes.
Oh, great. Let's see. How much do you get for the x?
X is 0 or -1.
Okay, that's great. Philip, how about you?
Same.
The same? That's so right. As you can see, you can write equation like that. 4 to the power x squared plus 3x equals to, for 16, you write that, I should say, 4 to the power 2, and you have everything to the power 2x. Then it can be written as 4x squared plus 3x, which equals to what? 4. You multiply this to this, becomes 2x, correct? Then now you have the bases equalized, then you can convert that. Okay, in that case, I can write x squared plus 3x should equal to 2x. Then you can just simplify that, the x squared plus x, because you take 2x to the other side, equals 0. You factor the x, then it becomes x plus 1 equals to 0. Then you get x, as you said, equals to 0, and x equals to -1. Great job, guys. Fantastic. So impressive. So impressive. Okay. Okay, now, guys. And now, what else can we do? We are now slowly getting into the second type of exponential equations. And for this type of the exponential equations, but the thing which we plan to do is this. We say that, okay, at this stage, I'm going to give you this example. We solve that together. Let's solve this one. 4 to the power, let's say, put this 3x minus 1 equals to 8. Guys, how about this one? Do you want to spend 1 minute to see if you can just find any strategy? Okay, are you done?
Not yet.
Not yet. How about you, Philip?
No.
Not yet. Guys, do you mind if I continue and you just help me to do this?
Yes.
Yeah? Great. Guys, now, what we plan to do. The plan which we have is this. We say that for this function becomes very easy. First of all, I think what happens if I take 1 to the other side in order to isolate the terms which they have the x as an exponent and the signs which they are all non-variables. That's the normally the routine which we do. That's right. That the thing which I mean that by this to write, for example, from this one, we can move to this. I write 4 to the power 3x equals to what? 1 plus 8 becomes what? Becomes 9. Correct? Does it make sense? Isolate similar terms on either sides of the equation. The unknown terms on the left and the known terms on the right. That's what I did. That was the goal of the thing which I did. That's right. Okay, and now, is it possible, guys, like the thing which we did before, to equalize the bases? While I have the base 4, I have the base 9.
No.
Is it possible to equalize it?
No.
Yes? Rose, you said something?
Is it? Yeah, I don't think so.
So you said we can't do that?
No.
No, because it's impossible to express 9 in terms of 4 in an exponential format. Then what can be done now? What can be done? And in most of the cases, guys, that's what happens when you solve an exponential equation. Now, you have two weapons to deal with it. Imagine that, you know, guys, what's a cowboy? Yeah? A cowboy, you have two tools. You are riding on a horse. You have two guns and you shoot. And now you have two guns. You use that when you are dealing with this situation. And these tools are this. And these are the options which you have. Either you pick up, I should say, this one from the shelf. This is not a good color, huh? Log with the base E, which we learned we call that ln, correct? And also the log with the base 10, which we call that simply the log. That's right. Then we have two tools, either ln or the log. But the log, I mean the logarithm function, which has its base fixed at 10, right? I'm going to choose one of these ones and act it on this equation. What do I mean by it? I mean that, guys, what happens, because as I have, I should say, this equality, I know that if you remember from, let me put the notes here. Today, the date is, guys, is April 3rd, huh? April 3rd. Functions 11. Page 1. Page 2. I'm going to write page 3. Okay, and now, the thing which I have here is this. I have two functions, and I have two options, either the log or the ln. Do you remember that previously, as we thought, you learned this. You saw that we said that we have two options, exponential formats and the logarithmic formats. We can just move between these two options. And now I'm just going to move from the exponential format to the logarithmic formats, because you saw that there are two conjugate transformation, two mutual transformation. By saying that, I mean that if I take from both sides of this equation the log, I choose log, for example, with the base 10. If I'm going to do that, what's going to happen? Then it becomes the log of 4 to the power 3x equals to what? The log of 9, correct? And when I'm there, guys, when you just move on to a representation that is logarithmic representation, you find yourself that you have to use those 7 properties of the logarithmic functions. You remember we had a property that if you have a hat on the main drivers, it falls behind the logit function. It was property number what? Number 3. You remember that, Rose and Philip?
Yes.
That's right. I'm going to do that then, Rose and Philip. Then as a result, what's going to happen? From this stage, I'm going to have 3x. Guys, please help me. What should I write next? Log of what?
4.
4 equals to what?
Log 9.
To log 9. Okay. And what is the basis, guys?
10.
10. I'm not going to write it, but I'm going to write it in order not to get confused. Log 10. True? And now, guys, what is the nature of log 4 or log 9? Rose and Philip, do you have calculators?
Yes.
Yes.
Can you please punch in log 4 or log 9 to see what you get?
Log what?
For example, log 4.
Zero 0.6.
0.6. How about log 9?
0.9595.
95?
Mm-hmm.
That's right, because it's getting close to the point. Okay. You see that, guys, as a result, you will see that the log of 4 and 9, they are essentially some noun quantities, because when you put them, punch them into the calculator, you get a defined number. Do you see that? Huh? Then log 4 and log 9, which the bases are 10, they are the quantities which they are known to you. You can treat them as, for example, 3, as 5, as 10, correct? If that's the case, the thing which we can do here is what? Is that you're looking for the x. Then I can just find the x like that. I say x equals to what? Divide both sides by 3 times log of 4, which I have here log of 9 divided by 3 times of log 4. You see that? Any question? Did you understand what happened?
Mm-hmm.
Yes.
Because I had here x as an unknown, log 4 and 3 are my known quantities. I divide both sides by these known quantities to isolate x on one side of the equation. Then I say at the end, okay, it's going to be log 9 divided by 3 times of log 4. That's right. And you know these values, log 9, Philip said it's become 0.9. Log 4 is 0.6. You divide it by this one multiplied by 3, and you get the number for the x. But at this stage, we are done. We do not simplify that further because it gets too messy. You got it, guys?
Yes.
Do you have any questions?
No.
No?
No.
Then, guys, what is the moral of the story for this type of the questions? What do we understand from this type of questions? The thing which we understand is that if in exponential equations, you cannot equalize the base, you go to the logarithmic transformation, right? Then you take the log from both sides of the equation, use the properties of the logarithmic function to find the x, correct?
Yes.
Any questions, Philip and Rose?
No.
Fantastic, fantastic. Now, you know that when you do not ask a question, Rose, what happens? And Philip? Do you guess what happens if you do not ask questions? Do you know? I ask you questions. That's the thing when happens. When you do not ask questions, it's me who asks you questions. And now, hi, Gloria.
Hi.
Gloria, you are.
I'm sorry, I'm outside.
No worries at all. We can always remember, you can get the access to the content from, from the recordings which I posted on the website. You arrived at the right time because I'm going to ask people questions, Gloria.
Okay.
And now this is the equation which I have for you. I have 3. Yes, Gloria,
Yes.
you asked me something?
Pardon?
You asked something?
No.
No?
I'm in the car, so.
No worries. 3 times e, exponent is x plus 1 minus 5 equals to 7. And that's the equation which I ask you, please spend a couple of minutes, try to solve it based on the second strategy which you saw. Because in this case, you find it's not easy to equalize the bases, then you have to always adopt, I should say, that representation in logarithmic format. Then please spend a couple of minutes on it. I'm sitting here to just help you if you get any questions. Okay, guys?
Okay.
I'm gonna put this inside this beautiful cell. Okay, now we're doing with this one. Guys, you see that it's always good that you ask me questions. If you don't ask me questions, I get back to you with a question then. Then make sure if I ask you, do you have guys questions? Say yes and ask me questions. Guys. I see a smile on your face and you're telling me that you are doing a great job. Am I right? Are you smiling now?
Not
Yes.
really.
Okay. Are you done or?
Not yet.
Not yet. No worries. Take your time. Is it good to have 2 more minutes?
Yes.
Great. Gloria,
Yes, I'm here.
how are you doing?
Good.
I mean, I'm doing this exercise.
Okay.
Are you working on it? I know that you're outside and it's so
No,
hard.
I'm driving.
Okay, Gloria, I think that's a very yeah, tricky circumstances because you cannot write. If you are not in a situation to attend the class, it's okay. You can just watch the lectures when I post it on the website.
Okay.
It depends on you if you want to stay or if you want to leave, but that's one.
I can stay.
Okay.
I may
Okay.
go home later.
Yeah, but make sure that when you're at home, watch the video again. I'm gonna post it, you know, every night. I post a YouTube link. You can go there, you can watch it again, especially the beginning to see how you solve the exponential equations. Okay,
Okay.
awesome. Rose, Philip, are you done?
No.
You don't mind if I started it and you follow me and help me to finish it, huh?
Yes.
Yes, great, great. Okay, guys, what's happening there? I'm staring at the paper and I see something there. It comes to my mind, first of all, that I'm gonna deal with an exponential function because exponential function, because I see the unknown as an exponent part of the function. You see, I do not have the x on the base. I have the x part of the exponents of one term. Then as a result, I'm gonna call this one an exponential function, correct? That's the first thing. I identify this exponential function. Always there's an instinct telling me, omit, put all the exponent parts one side and take all the non-quantities to the other side. And I say, sure, I'm gonna do this. I'm gonna move from this part. Guys, you see that? It's a right angle. You see what I'm writing?
Yes.
Great. Then what I'm gonna do is that I'm coming here, I put 3, and look at this. This is E, the natural number. You know how much is that? 2.7. My exponent is x plus 1, and I take 5 to the other side, and it meets 7, and they summed up. 5 plus 7, how much it gets?
12.
12. Correct. Thanks, Rose. And this becomes 12. And now, I see, I have 3 here, multiplied to an exponential term becomes 12. Then guys, what do you think? In order to make the things much even easier, I divide both sides by 3. You cannot do that, but if you do that, things becomes more compact, much more neat. What do you think? Should I do that, guys? Philip, Rose, Gloria?
Mhm.
Yes.
It's a good strategy, huh?
Yes.
Yes. Then the next step, I'm going to do this. I'm going to divide both sides by 3 to end up with this. E to the power x plus 1 should equal to what? Equal to 4. Right? Okay. Now at this stage, I see that, okay, now I have a much neater function now. You see that? I have a much more neater function that I expected before. I started from this. Simply by some algebraic manipulation, I make it like that. Guys, can you come up with any strategy to equalize the bases? Can you do that? Yes or no?
No.
No, of course. It's almost impossible to equalize the bases when the base is e and the other base is 4. Then what should I do? My strategy is that to transform this exponential representation into a logarithmic representation, correct? In order to do that, I have 2 tools. The first tool which I have, it can be this. Either I'm gonna use log with the base 10, or I'm gonna use ln, which is the log with the base e. Guys, which one do you recommend? Log with the base 10 or ln?
Ln.
Ln? Why, Rose?
Because ln is the log base e.
That's so true. Then essentially, as Rose said that, I'm gonna choose ln, and my magic power, because I see the base here is e. You can use log with the base 10, but things is okay, but some computation is not as easy as if you get the ln of that side, correct? Then what I'm gonna do, I'm gonna take from both sides of this equation ln. Then it becomes what? It becomes ln of e. Exponent is what? X plus 1 equals to ln of 4. Correct, guys?
Yes.
Everybody has questions so far?
No.
Gloria,
Yes.
do you have a question?
No.
How about you, Philip?
No.
No, so far so good. Now, guys, now when you are transforming yourself from exponential representation to logarithmic representation, you have to prepare yourself to use those 7 properties that you learned. Do you remember those properties? We had 7 properties. One of them was the fact that if the main driver is wearing a hat, the hat is gonna fall down behind the car. That's right. Then it means what's gonna happen? It means that you are gonna end up with this. You say that x plus 1, it's gonna go multiplies to ln e equals to ln 4. Correct?
Yes.
That's right. Okay. At this stage, guys, I'm looking back again. Can you identify any one of those properties, 1 to 7, of the things that we discussed about that last week? Can you identify anything inside the equation which I'm going to highlight it? Do you see any other property which you can use it here? Can you identify that? X plus 1, all is multiplied to ln e equals to ln4. Give it 20 seconds. Can you identify any property 1 to 7 from last week?
Property 1.
Property 1. What does property 1, Rose? We said that the log. Yeah, please say that, Rose.
The log
Say what?
b base b equal to 1.
That's so true. Equals to 1. It was property number 1. We said that if the main driver and the passengers are the same, we get it as 1, and it was so easy to prove it. If you transform that into an exponential format, you see that that's a very reasonable identity. Then as a result, if I look back here, I have ln e. What is ln e, guys?
1.
ln e is actually log, everyone sees here if I'm writing, log e with the base e. Is it right, Rose, Philip, and Gloria?
Yes.
Yes? Yes, Philip?
Yes.
Then from property 1, which Rose mentioned, then it has to be also 1. It means that ln e also equals to 1 because ln e is log e with the base e. Then you see the base and the main driver are the same, then becomes 1. Then into this equation, ln e is what? 1. 1 is multiplied to x plus 1, correct? Correct, guys? Then what I have x plus 1 times 1, which is going to be x plus 1 itself, should equal to what? ln 4, right? What is x now then?
ln 4 minus 1.
So true, ln 4 minus 1, because ln 4 is a number. If you put that, for example, I think Philip got it around 0.6. That's right, Philip?
Yes.
That's right. Then it's a number. Then I can treat it as a known quantity. And if I take 1 to the other side, I get an explicit representations for the x, right? And there I am. And I solve this equation in a spectacular way. How neat. Guys, any question, any questions which you need to clarify some stuff for yourself?
No.
No? How about you, Philip?
No.
No? And I'm sure Gloria has no question. Okay, what page number was that? 3? It is page number 4 here. Okay, page number 3, page number 4. There we are. Guys, are you ready for the last question? Then we just go for the break?
Yes.
Yes? Nice. Okay, let's go with this one. Let's go with this very simple example. I say that 5 to the power x plus 1 equals 6 to the power 2x. I think that's a very easy one. Please, guys, just spend a couple of minutes, try to solve this, then we just work it together. Please, thanks. Guys, any questions? Guys, are you done?
No.
Not yet? Philip, how about you?
No.
Not yet. Listen, the şarj nerede? Sürer zaten. Okay, can I just start and you guys please help me to continue and we finished it together?
Yes.
Yes? Awesome. Guys, first of all, I look at that thing and that's an exponential function beyond doubts because the unknown is as an exponent part of the function. Okay, now, I ask myself now, can I equalize the bases?
No.
No. Then I'm going to transform this exponential representation into logarithmic representation, correct?
Yes.
Okay, I have two tools to use this. I can either use the log or ln. What do you recommend? Both of them are possible, but depends which one is the easier one. Which one do you recommend?
Log.
Log? Rose recommends log. How about you, Philip?
Log.
Log, that's right. I'm not asking Gloria because she's not doing it. She's in the car, but she promised me to just watch the video sometime later. Then I'm going to use log. You can use also ln. Yes, Gloria?
Oh, no.
Yeah, it's fine. No worries. Take it easy. Then I ask myself, I can just use also ln, but the ln also gives you the result, but it's not as easy as the log with the base 10. Then if I get the log, what's going to happen? It transforms it to logarithmic representation equals to the log with the base 10 of 6 with 2x. Then you know that when you are in the logarithmic representation, you have always 7 important properties that you can use. Here, which property is obvious?
3.
Huh?
Property 3.
3, that's right, Rose, because I see I have a hat. It falls behind the car, and also this driver has a hat. It also falls behind the car. Then from here I have what? I have x plus 1 times the log of 5 equals to what? 2x log 6, correct? Okay, now, guys, what do you recommend now? Imagine this one as 2 log 6 times x, because log 6 is a number. It's multiplied by the log 6. It's by 2. From here, what do you recommend? What should I do? Huh? Nobody just wants to say anything? Guys, is it fine if log 5, which is a number, I expand it into the expression x plus 1? Once multiply it to 1 and once multiply it to x. Do you think it's a good idea? Yes? I'm going to do this. I say x log of 5 plus log of 5 times 1 becomes how much? Log 5 equals to what? 2x log 6. Okay. I know that the log 5 is a non-quantity. That's right. Then, okay, at this stage, as I know that the log 5 is a non-quantity, I keep it to one side, take the other expression to the other side, correct? In order to isolate the unknown quantities. Then from here, I'm going to write this. I'm going to have log 5 onto this side of the equation. And I'm going to have what? I'm going to have 2. Let me write with the same color. 2. Guys, I'm going to take log 6 in front of the 2 because this is a constant coefficient, huh? 2 log 6 times x, it goes to the other side, correct? Becomes minus log 5x. You see what's happening, guys? Remember, if you do not ask questions, it's me who is asking questions from you. You see how did I get from here to this?
Yes.
Yes?
Yes.
You see that? Always look at the log 6, log 5, and log 5 as a noun quantity because it's like the pistachio. You open it, it's like a dumpling. You open the dumpling and you see what is inside. I'm just going to use this strategy to solve an equation that I isolate the unknown quantities on one side, non-quantities to the other side. I say x and x in these two terms, they are going to be unknown quantities. I'm going to keep this one on the right side and take this one to the other side. This term, I can take log 6 in front of 2. Huh? Because imagine log 6 is 1.7, for example. 1.1. Then it becomes 2 times 1.1 times x, becomes 3x, for example. And the same thing here, log 5 can come in front of the x. It doesn't make any difference because that's a constant which is multiplied to the x. That's right. Then this term becomes 2 times log 6x. If this one goes to the right side, becomes minus log 5 times x, correct? And I have my log 5 to the left side, which is a known quantity. Any questions, guys? Are you sure you understood what happened?
Yes.
Awesome. Then what's going to happen? I'm going to write the same thing again. I'm going to write log 5 equals to, I'm going to factor x by writing 2 log 6 minus log 5 times what? Times x. Correct? I factored out 6 from the right side. Make sense?
Yes.
Now, the question is that Rose, Philip, and Gloria, how much is the x? How much is that, guys?
Log 5 over 2 log 6 minus log 5.
That's right. I divide both sides of the equation by the coefficient of the unknown, which is 2 log 6 minus log 5. Becomes 2 log 6 minus log 5. Everyone can see what is written here?
Yes.
Yes, Philip?
Yes.
Awesome. Then, guys, and the problem is now solved because I know what is log 5. I have a calculator. I put it there. I know what is log 6. And 2 times of the log 6 is easy in the calculator to find it. And I can get the numerical value for the x. Right?
Yes.
Guys, please close your eyes and make sure that you have understood this perfectly. Ask me questions if you didn't get it. Philip? Do you have any questions?
No.
No? Rose, do you have any questions?
No.
Gloria, do you have any questions?
No.
No? That's great. Then guys, the time is now 7:04. Please take 15 minutes break. Please come back by 4:90. Sorry, not 4, 7:90. Okay, almost 7:20.
Okay.
Is it fine?
Yes.
Yes. Then guys, I see you in 15 minutes. Enjoy your break. When you come back, we do more practice then. Okay?
Okay.
Fantastic. See you later. Hi guys.
Hi.
Are you back?
Yes.
Who is back? Rose is back. Philip is back.
Yeah.
No, not Philip back. Philip is not back.
Yes,
Gloria is back.
Gloria back.
Great. Guys, what has happened to Ferris? Okay, guys, we solved only 2 problems and we finished the class today earlier than we expected because this is Friday. I'm sure that you just want to spend the rest of it having some fun. But guys, as you know, I have posted something online that you are just going to have a test on Monday on logarithmic equations. Okay,
Okay.
on Monday there is a test. You are excited, huh? Everyone's excited. I'm sure Gloria loves to write the test on Monday. How about you, Rose?
Not really.
Not you. How about you, Philip?
No, I'm not ready.
But you love the idea of having a test. But it's a very easy test. If you follow the things which we did in the class, especially the examples which we solved, you are going to have something very similar like that on the test. Okay, we're going to just solve this one. Now let's see, maybe that's going to be the last example. Okay, let's do this one. 2 times e to the power of, guys, by the way, how do you like the online classes? Do you like the online classes or you prefer the ones which we had in the class?
I like to study in school.
School, that's right. How about you, Philip?
It depends.
On what?
If you like, more
Do you
care
like to-
about the learning quality. Learning at school is good, but if you're just trolling in the class, maybe online is good.
Oh, I understand. But what is good for you, for you personally? You think the class is good in the school or the online?
I think both is okay for
Both
me.
is okay. Nice. How about you, Gloria? Do you like online classes or the school ones?
Gloria is not here.
Not here anymore, huh? She's
Yes.
gone? Okay. Nice. I personally myself, I like, to be honest with you, go back to school. -7, but at the same time, studying online, it's good that you do not have to commute. 7e to the power of the x becomes 15. Okay. And now we want to solve this equation, guys. Do you like to spend some time on it?
Yes.
Yes, please. And I'm here, guys, in case if you have any questions, please ask me in the process if you need some clarification or need help.
Okay.
Yeah, thanks. Guys, are you done?
No.
Not yet. Do you need more minutes?
Yes.
Yes, sure. How about you, Philip? Do you need more time?
Yes.
Yes, please. Are you done? Not yet?
Almost.
Almost. That's great. That's good news. Almost is a promising word. Guys, are you done?
Yes.
Oh, that's great. Okay, let's see what you did so far. Okay. Okay. That's a tricky question, huh? Okay. Let's first of all, guys, it seems that we have more terms which they are exponentials, and there is no question to equalize the basis of these terms. That's right.
Yes.
It's impossible. There is no way even to think of it. Then the best thing is that to transform this exponential representation into a logarithmic representation, right? In order to make that transformation into the logarithmic representation, what do you recommend? Log with the base 10 or ln?
ln.
ln. That's so right. I'm going to use the ln now. Just continue to see how far I can go. I'm going to write the ln from both sides. Then I have ln of 2e to the power 2x minus ln of 7e to the power of the x equals to what? ln of number 15, which is a known quantity itself. You can find how much is that in using your calculator. So far, so good, guys. I
Yes.
take ln from both all terms. Do you think this is a correct approach? Do you think did I do something right? Did you do the same thing or different?
Oh, it's the
Same
same.
thing.
Did the same thing?
Yes.
That's right. Okay. Now, there we are now. We took ln from each element, and now what are we going to do? The next step, I'm just going to just use some, because now that we are working in the logarithmic representation, then now it is necessary to use one of those 7 properties that we've worked with it before. That's right. Can you use any properties?
Property 3.
Say what?
Property 3.
Property, which property you think?
3.
3. And Rose, you just telling me something which it puts me into deep thoughts. Property number 3, you mean that I can just, for example, use 2x pulling up before ln, huh?
Yes.
But does 2 also have the same exponent as the e?
Oh, no.
No. Then the problem is the 2, because 2 is not letting you to do that, because 2 says that, okay, I don't have the same exponent to do this. Also 7 here. 7 also is telling you, you cannot take the x to go to the other side. You can just, for example, if you had ln ex, it was easy. You could just take the x to the other side, right? But 7 here, it stops you from that, because 7 doesn't have the exponent as the x. Do you get the difference now, Rose?
Yes.
How about you, Philip?
Yes.
Yeah, you got it. It's a very tricky point. It's a very tricky point. Then if we see that, we cannot do that. But there is one condition that we can just use property number 3. What is that condition? Look at the first term, guys. I'm so glad we have this example, because this example is one of the best ones. Look at this example. Can I use property number 5 on this first term, and using that in order to extract 2 from e to the power 2x? You wonder, how is that possible? Let me do that. I say this one. Can I write the first term as ln 2 plus ln e to the power 2x? Can I do that? By using property number 5?
Yes.
Yes, because I say that 2 is multiplied to the e to the power of the 2x. Then if I have two functions which are the product of each other, it means that they are multiplied. I can just decompose them into two logs of individual functions. Yes, Rose?
Yes.
Yes, Philip?
Yes.
That's right. And now, how about the second term? Can I do the same thing with the ln 7e to the power minus x?
Yes.
That's right. Then I can do the same thing there. I keep my minus sign there, and I use that thing then. Then becomes minus, it becomes ln 7 plus ln of e to the power of what? X, correct? Guys, take notice that I just put the minus sign before the parentheses. That it means that I have to act it on these two terms. Equals to what? ln 15, correct? Okay, now. Any questions, guys, so far? Any questions?
No.
No?
No.
How about you, Philip? No? Okay. And now, guys, getting to this point, can I use now property number 3 or no?
Yes.
Can I use that now?
Yes.
That's right. Guys, look at that. Previously, when I was working on this, I couldn't do that because 2 was impeding me, stopping me to just take 2x to the other side. But now I have 2x simply here, huh? And x here, there is no problem then. Then I can take them back to the function, correct? Then I can simply, from here, I can reach to this point. I can write ln 2 plus 2x ln e, correct? Minus ln 7 minus x ln e equals to what? ln 15. The only thing which I did was that I took these powers behind the logarithms using property number 3 and expanding minus before the parentheses into each term. Then both of them becomes minus. Correct? Any questions, guys, about this step?
No.
No. Guys, what property of logarithmic function you can think of now when you're at this stage? Rose, Philip? Look at ln e. ln e is property 1, that the base and the main driver are the same, then the log is going to be 1, correct?
Mm-hmm.
Then as a result, I can simply come to the next stage and replace ln e with 1. Then what I get ln 2 plus 2x minus ln 7 minus x ln e becomes 1 equals to what? ln 15. So far, so good, guys?
Yes.
Yes, Philip?
Yes.
And now look at this one. We have ln2 is a noun quantity, right? We have ln7, that's the noun quantity. And we have ln15, it's also a noun quantity. But 2x is unknown and minus x. Then what is the strategy now? The strategy is to isolate the unknowns to one side and nouns to the other side. Imagine I keep 2x and minus x to the left and take all the noun quantities to the right. How much is 2x minus x, guys?
X.
X. That's so true. I have x and I keep it on the left side of the equation. And I take the other terms all to the right side. I have ln 15 as a noun quantity plus ln 7 minus ln 2. Guys, do you see that green color or no?
Yes, I can see it.
You can see that? How about you, Philip?
Yes.
You can see that?
Mm-hmm.
That's right. Super. Then as a result, guys, congratulations. You solve this equation. And you got the x. It's the linear combination of ln15, ln7, and ln2. And each one you can put that in your computer or calculator to get the numerical values. Then you see what is the end results for the x. Right?
Yes.
Awesome. Did you get to the same result?
No.
How about you, Philip?
No.
Okay, no problem. But it was a very interesting question because there was a twist here. You see that? For the 2e to the power of 2x, there was a twist that you had to use property number 5 before using property number 3. Beautiful question, huh?
Mm-hmm.
Do you like that to be on the test Monday?
No.
But you should say yes, because you learned how to do that, then it's an added point, bonus point on the test because you know what is the answer. Am I right, Philip?
But still too hard.
Oh, really?
Yeah.
But that's a good thing that you get exposed to this type of the problems. How about you, Rose? Do you want to be on the test on Monday?
No.
This one, I believe that it was a little bit tough. And you're not going to have these kind of questions on the test or midterm or the final test. You have much easier ones that you can do that very easily. This one, it was tough. Are you happy now, Philip and Rose?
Yes.
Yes.
Awesome. But it's good that to learn how to these ones because when you go to advanced function, you know lots of their stuff.
Mm-hmm.
An advanced function class for you becomes like the break. You just get there, you listen, and you say, oh my God, I know everything there. But these type of questions is not going to be on your test, midterm, or test, or quiz, or final. Okay, can I remove the page? You are done?
Yes.
Sure.
Page number 6. Guys, is it okay if we just do the last question, then the finish?
Yes.
Okay,
Yes.
I make this one easier, that doesn't take much time. Then it means that you are doing good enough practice for the test on Monday. Okay, now. I'm going to give you something very similar to make sure that you got the thing which we did now. The equation is this. It is 3e to the power 2x minus 4e to the power x minus 7 equals to minus 3. You see that, guys?
Mm-hmm.
It's okay? Awesome. It's almost 100% similar to the previous one. Then as you do not have it on the test, it's true, but it's good that to practice because it makes you be perfect on the simpler stuff, which is going to be on the test then. Is it good if I give you 5 minutes to work on it, or you want me to start right now? You help me. You want a couple of minutes to work you first?
Yes.
Awesome. Then I'm here. If you need any help, just let me know.
Rose
啊，
咋弄啊？
就先把7挪过去，
嗯
然后都带入 ln，
嗯
然后它 ln，然后再把它们分开，就是分成，比如说这个3e 2x，它分成 in3加上 in1 2x，in1 不是等于1嘛，
嗯。
然后就这样算就行。
哦，哎，那个1前面有东西吗？我感觉我这好像看不全。
好像前面是个3吧？
哦，你也看不见了。我还以为我手机有问题呢，吓死我了。基本上 YouTube 看一眼了，哎，都没怎么听今天。
Guys, are you done? Yes?
Yes.
You're done?
Yes.
Awesome. How about you, Philip?
I'm done.
Okay. Now, guys, let's help me to just solve this one. And you just please give your idea advice. Guys, I'm just going to write, but I'm listening to your advice. What is going to be the first step to solve this equation?
Oh, I cannot see it. Oh, yeah.
You do not see that?
No, I can.
Is it fine now?
Yes.
Yeah, awesome. Guys, what is going to be the first step?
Move the 7.
To the right side, you mean?
Yes.
That's right. Then I'm going to have 3 to the power e to the power x to x minus 4 e to the power of the x equals to 7 goes to the right side, becomes plus 7. Plus minus 3 plus 7 minus 3 becomes how much?
4.
4. That's great. Fantastic job. Fantastic. Thanks. Okay, guys. What's the next step now?
Use ln.
That's right, because I cannot equalize the bases. I transform the exponential representation into logarithmic representation. And I use ln. Take the ln from both sides, correct? Then it becomes what? It becomes ln 3 e to the power 2x minus, oh no, minus ln 4 e to the power of the x equals to what? ln 4. Correct, Rose and Philip?
Mm-hmm.
That's right. What's going to be the next step?
Use property 3 for 5.
Property 5 on which term?
The first term.
That's right. And can you tell me what is that going to be then, the result?
in3 plus,
You mean ln?
oh yeah, ln 3 plus ln e power to 2x
Okay. What's next?
and minus ln 4.
Do they have a big parenthesis or no?
It can have
Then becomes what? ln?
ln 4 plus ln ex e power to x.
That's right. Equals to what?
ln 4.
ln 4. That's fantastic. Thanks so much, Rose. Philip, are you okay? You have done the same thing?
Yeah.
It seems that you are doubtful. You have some doubts.
No doubt.
You are totally fine?
Totally fine.
Awesome, awesome. Okay, Philip, then that's your turn now. What is going to be the next step?
Next step is
Which property you think is most relevant?
3.
Property 3. On which terms?
What do you mean by which term?
I mean, which terms in the equation they require property number 3? You mean this one, huh? That's right. I fallen behind the equation. That's right. And it's going to be ln 3 plus 2x ln e, that's right, minus ln 4 minus x ln e equals to ln 4. That's correct, Philip?
Yes.
That's right. Awesome. What's going to be the next step, guys? Which property you can use it right now?
Property 1.
1? What do you mean by that? Which term needs property number 1?
ln e
ln e becomes
1.
1. Then can you say me what should I write then?
ln 3
Okay.
plus 2x minus ln 4
Okay.
minus x
Equals to?
ln 4.
That's right. Yes, Philip.
Yes.
So far, so good.
Mm-hmm.
That's right. And now, what's going to happen next? From this stage, what should we do? Because ln3, ln4, both of them are non-quantities. What's the strategy at here?
Move it to the right side.
That's right. I isolate the unknown quantities to the left, take the known quantities to the right. 2x minus x becomes how much?
X.
X equals to, I keep ln4 to the right. I take ln4 to the right also, minus ln3. Can I simplify that further? Philip, can I simplify this stage further? I have 2 ln4, 1 ln3.
Where did the 2 go?
Huh?
Where did the 2 goes?
Do you mean this one?
Yeah.
I have 2x here, Philip, and I have minus x there.
Oh, so.
Ah.
I thought it's a bracket.
Yeah, I just removed the brackets by having minus going to both terms. Then here we used ln e equals to 1 property. Then we ended up here. Then 2x minus x becomes x. I have ln4. Take ln4 to the right side becomes plus ln4. And ln3 go to the right becomes minus ln3. Then I have x equals to this. You are fine here, but I was wondering, can you simplify that further? I have 2 ln4, 1 ln3. Philip, can you think of something that we can do? Rose, how
Add
about
it
you?
together or?
Yes, say that again.
Add it together.
How?
I don't know.
ln4 plus ln4 becomes how much?
ln8.
Oh, that's the thing which I was wondering. Some of you says that. Guys, ln4, you cannot add them, say ln8. You know why? Guys, do you know what is a lobster? How about you, Rose? Do you know what is a lobster?
Lobster.
That's right.
What's that?
龙虾.
Oh, I got it.
That's right. It's a kind of a seafood. Imagine when you want to eat a lobster, you cannot put it in your mouth and chew on it. You have to remove the crust, the red crust on top of it, then they eat meat. ln is like that. You have to remove the ln before you add 4 together, then becomes ln8. ln4, imagine 1 lobster becomes how much? 1 lobster plus 1 lobster becomes 2 lobsters, huh? Then becomes 2 times ln4, right? Right, Philip?
Yes.
And you have also minus ln3, which comes at the end. I was waiting on this because I did the same mistake when I was at high school. I was adding ln4 plus nl4 becomes ln8. Then afterwards, I noticed that they are become lobsters, like the lobsters. 1 lobster plus another lobsters becomes 2 lobsters. You see that, Philip?
Yes.
Does it make sense? Awesome. Any questions, Philip?
No.
Are you happy with the course, with the content?
Yes.
Awesome. Rose, any questions?
No.
Are you happy with this problem? No questions on this problem?
Yes.
You mean you have a question?
Oh, no, I don't have
No.
a question.
Fantastic. Guys, it's sharp 8:01. I want to say enjoy your weekend then. I see you back on Monday with a very simple test. Awesome. Then guys, enjoy your weekend. See you on Monday.
It's a quiz or a test.
It's a simple test. It's bigger than the quiz, but it's very easy, very easy. Review all the things which you have done in the class and you should be fine.
Okay. No
And
problem.
try to go to the homework which I have posted. Try to review that and do as much as you can. I
Okay.
have posted something, it is called a logarithmic function. There are almost 70 questions. Try to review them. Do as many as you can. Awesome. Okay, Philip.
Okay.
Awesome. Okay, Rose.
Okay.
Awesome. Guys, enjoy your weekend. See you all back on Monday then.
See you Monday.
Thanks. Have a good night.
Bye.
Bye-bye. Bye.